Now let us see how we can use a binomial theorem in the divisibility problems. That is, uh, there are some questions in which we have to either prove that certain expression is divisible by some term, or sometimes we have to find the remainder when one number is divided by another number. So let us see how we can solve these problems using binomial theorem. Now to begin with, let us recollect the expansion of 1 plus x raised to n. As we know, it is as shown here, that is 1 plus nc1x plus nc2x square and so on. Now if we take 1 on left hand side, what we will obtain is 1 plus x whole raised to n minus 1 is equal to, so out of the remaining terms on the right hand side, we observe that we can definitely take x common, and hence in the bracket we will have nc1 plus nc2x plus nc3x square plus so on up to lastly ncn x raised to n minus 1. So basically it's clear that the expression which is on left hand side, that can be written as x into some particular number. So therefore it means that the expression which is on left hand side is divisible by x. So that way we try to show that if particular expression is divisible by x, then we use the binomial theorem in this particular manner. Now let us solve few questions so that this idea will be clear. Now here is the first question, that is, we have to show that 2 raised to 3n minus 1 is always divisible by 7, where n is a natural number. So we are given an expression of the form 2 raised to 3n minus 1. We have to show that it's always divisible by 7. Now let us start off with the given expression, and we will try to write that as 7 into some integer number. Alright. So here to do that, first let us split 3n as 3 into n. So using laws of indices we can definitely write this. Now this further is equal to 8 raised to n minus 1. Alright. Now we see that the number with which we have to check the divisibility is 7, and that is very much close with number 8. They just differ with 1. So therefore we can write this particular 8 as 1 plus 7 whole raised to n minus 1. Okay. Because why do we write 8 as 1 plus 7 and why not 2 plus 6? Because the very reason is that we just saw previously that we have to make use of the binomial expansion of 1 plus x raised to n. So we must have this particular 1 present. So that is what we try to achieve. Now moving ahead, if we expand this 1 plus 7 raised to n, we will have the first term as 1 plus next term would be nc1 into 7 plus next term is nc2 into 7 square plus so on to last term will be ncn into 7 raised to n, and from this we have to subtract minus 1. Right? So therefore 1 will get cancelled, and from the remaining expression, if you observe, we can always take 7 common, as various powers of 7 are present. So if we take 7 common, we have nc1 plus nc2 into the remaining 1 factor of 7 and so on, and the last will be ncn into 7 raised to n minus 1. So thus we see that now this can be written as 7 into some integer n, because this particular bracket is definitely an integer and not any fraction or something. So therefore we can now say that since n is an integer, rather it will be in fact a natural number. So therefore it's clear that the required expression, that is 2 raised to 3n minus 1, is divisible by 7. Let's see another question, a different variety based on the divisibility. Now here we have to find the remainder when 7 raised to 103 is divided by 25. Now in this type of question, what do we do is we try to find out the power of the base, that is here the base is 7. So we somehow try to find some power of 7 which is very close to the divisor 25, and by very close we mean it should differ only by 1, because only then we can make use of the previously seen binomial expansion. So here if we think 7 is very far away as compared to 25. If we consider 7 square, which is 49, then you see that 49 is very much close to 25 into 2, which is equal to 50. So you see 49 and 50 differ just by 1. So now therefore we make use of the second power of 7, which is 49. So we'll have to do a little bit of adjustment in the given number. So let us see how we can find out the remainder. Now also on a side note, we know that whenever we have some number which is divided by a divisor, we can write that as some quotient plus the remainder upon the divisor. So that means if we can rewrite the number upon divisor in this particular form, then whatever is the number here r, that is nothing but the remainder. So therefore let us try to express 7 raised to 103 divided by 25 in the required format. Okay. For that we have just seen that somehow we have to write some power of 49, because we have identified 49 as the power close to some multiple of 25. So here I can write 7 into 7 raised to 102, alright, and divided by 25. Now moving further, we can write this as, now from this 102 I extract one factor of 2, so therefore what remains is 51, alright, whole divided by 25. So that is nothing but 7 into 7 square is 49 whole raised to 51 whole upon 25. Now as we know, the whole purpose was to find some number which is close to some multiple of 25. So therefore we write 49 as 50 minus 1 whole raised to 51 divided by 25. Right. Now as we know, this 50 can be written as 25 into k, where we know that k is actually equal to 2, but this can be written as 25 minus k upon minus 1. And now since what happens is we have 50 minus 1 whole raised to 51, therefore we can write this as 7 into 25k minus 1 whole upon 25, because we can always write some constant k which is multiplying 25, and then we have to subtract minus 1 and then divide by 25. Now moving ahead, if we split this, because we have to finally bring it in the required form of q plus r by d, we have to also remember that the remainder that we are talking about, that must be a positive number. So therefore if we split it right now, we will get minus 7 by 25, which is what we don't want. So therefore we will have to add and subtract the divisor, which is 25. So therefore what do we do is 7 into 25k. Now to this we first subtract 25, therefore we have to add 25, and then we subtract minus 7, because it is a product of 7 and this minus 1, and this whole thing is divided by 25. So that further gives us 25k into 7 which is nothing but 175k. So that we can write as 175 k minus 25 plus, now we will club 25 and minus 7, that is nothing but 18 whole divided by 25. Yeah. So now that further is equal to, now if we take 25 common from the first two terms, then we will have 25 into bracket 7k minus 1. So that is the first term. Here we get some multiple of 25, and since k is an integer, 7k minus 1 will also be an integer, whole upon 25 and the second term is, the remainder part is 18 divided by, the remainder is 18 divided by 25, which is the divisor. So therefore here if we compare with the required expression, you see in the first part the 25 will get cancelled and the 7k minus 1, which is shown here, this will be the quotient, and in the remaining part we have remainder as 18. So therefore our answer is 18.